Hello students, today we are going to study about nucleophilic substitution reaction. Alkyl halides shows the three types of reactions. The first one is your nucleophilic substitution reaction, second one is your elimination reaction, and third one is your reaction with metals. So what I have told you, this is your alkyl halide. These alkyl halides is showing us three types of reaction. The first one is your nucleophilic substitution reaction. Second one is your elimination reaction, and third one is your reaction with metals. So first of all, we are going to study what is mean by nucleophilic substitution reaction. When a group bonded to carbon atom of substrate is replaced by another group is called as nucleophilic substitution reaction. So what they have said in this definition, they are saying that when a group is bonded to carbon atom which is of substrate is replaced by another group, such a reaction is called as nucleophilic substitution reaction. Okay, now very important point that we are going to study over here. In nucleophilic substitution reaction, the hybridization of carbon remains same. So in nucleophilic substitution reaction, hybridization of carbon remain same. To understand the nucleophilic substitution reaction, we are going to take a general reaction. I am going to take methyl chloride and OH minus. When the reaction is taking place, the bond which is present in between your carbon and chlorine gets broken. To the position of chlorine, your OH gets attached. So you will get a product CH3OH and Cl minus comes out. This Cl minus is called as leaving group. And one thing you should know that this OH minus is very good nucleophile. When the halogen gets come out, it will pull the electron towards itself. It will pull the electron pair towards itself, due to which this carbon becomes electron deficient. Why? Because halogen, which is a very good leaving group, has taken the electron pair. So due to this, carbon atom becomes electron deficient. That is nothing but it is become electrophilic, which is also called as electrophilic center. So what happened in this reaction? In this reaction, electrophilic center is generated, and on that electrophilic center your nucleophile is attacked. Now second point, we are going to study the factors which is affect on nucleophilic substitution reaction. Okay, so this is next point. Reactivity of nucleophilic substitution reaction. This is one of the factors. Reactivity of nucleophilic substitution reaction. Okay, so there are two factors which affect on the reactivity. The first one is your substitution state of carbon atom. State of carbon atom, and second one is your nature of halogen. So these two factors are affect on reactivity of nucleophilic substitution reaction. So to understand these two factors, we are going to take the examples of types of alkyl halide. So this is your tertiary alkyl halide, this is your secondary alkyl halide, and this is your primary alkyl halide. To understand the point, substitution state of carbon atom, in this point we are going to study tertiary alkyl halides are more reactive towards nucleophilic substitution reaction than your secondary alkyl halide and primary alkyl halide. Now question arises, why these tertiary alkyl halides are more reactive for nucleophilic substitution reaction? The reason is that because tertiary alkyl halide can effectively dissociate into halide ion and carbocation. Okay, so due to which tertiary alkyl halides are more reactive towards nucleophilic substitution reaction. Next point, we are going to see the nature of halogen. To understand again this topic, I am going to take the another example, that is nature of halogen. Here I am going to take methyl iodide, second one methyl bromide, and third one is your methyl chloride. Methyl iodide, methyl bromide, and methyl chloride. So in this case, all are same types of alkyl halide, same types of alkyl halides. Okay, so now question arises, why this CH3I is more reactive towards nucleophilic substitution? So here one point you should know that the size of iodine is very large. Due to large size of iodine, bond length is large but bond strength is less. So bond length is large and bond strength is less. Okay, so less amount of energy required to break this bond, the bond which is present in between carbon and iodine. So due to this, iodine gets separate out easily, and to the position of iodine your second nucleophile gets easily attacked. So that's all about nucleophilic substitution reaction. In next lecture we are going to study about SN mechanism. Please like, share and subscribe my channel.